Hi guys, short video about alpha radiation. Now, as we all know, some elements are radioactive, and alpha radiation means, in fact, chunks of helium are snapping off. And in fact, I don't think it's proper radiation. Gamma radiation travels at the speed of light. Gamma radiation, I think that's radiation. Alpha radiation, the chunks of helium that snap off an atom's core, they travel max 10% of the speed of light. So that's more like an object breaking off and then flying into space than actual radiation. But let me show you in detail what alpha radiation is, how it works. Over here we have curium, the completed 7th shield, and as you can see, it's almost a perfect sphere. This is the atom core, by the way, the atom core of curium. It's almost a perfect sphere, if not for those 8 tripods, the 8 of those tripods sticking out, and they make it look like some kind of a sea mine, but it's almost a perfect sphere except for those tripods, as you can see. Now, a tripod, it's more than just 3 Q-tips. In fact, if you take, this is how I build atoms. You start out very small, and then you see, this is just a rake model of an atom. Every nucleon is made out of 3 quarks, and 2 are spinning the frame. So every nucleon has 1 quark that makes it for the framework, and the other ones spin around, either as a neutron like here, or as a proton having 1 electron in orbit. So this is the only difference. It's actually one complete thing. There's not charge involved, anything. It's just mechanical. They are ball-shaped springs, if you will. It's the centripetal force that creates the protons. Now, so this is in fact a small detail of an atom. This is more simplified, using only the structural members, and then you can scale it down to this. In fact, that is what you see when you look at a curium atom or any atom I make. They all, well, they're very simplified. These are skeleton models. So the surface, in fact, would be like this. If you see, this is a tripod. You can see it on the blue, the 3 blue legs sticking out. This is a tripod, and which means it represents that thing. Now, a tripod is, unlike the name, it's made out of 4 nucleons in total. You got 1 on top, holding the other 3 in place, and this one does not spin. It cannot spin. It's gridlocked. It's just there as a structural support. Now the other 3, those legs, they have spinning nucleons, and as we know, of those 3 ones, only 2 can decay into protons. Now, if you have a 4-part, like say oxygen, this is oxygen. In fact, this is water. This is water, and you see the yellow thing, that's oxygen, and you see 2 4-legged pyramids, bottom to bottom. Well, 4 legs can spin as a whole. 2 times 4 makes 8 protons. Now, if you look at carbon, this is in fact methane gas, but again, look at the yellow structure, that's carbon, and you can see that I flagged down using a piece of black tape. I flagged down one of those legs because you can only have 2 spinning protons in a tripod. Say if you want to let another one decay as well, it'll gridlock. The whole thing cannot spin. We know why that is, of course. Clockwise, anti-clockwise, clockwise, anti. Oh wait. So there's, see, it gets gridlocked. So this is a even number, and this is an odd number of legs, which means one has to remain a neutron, right? So that's why where's my little? Oh, there it is. There's this tripod, and only 2 of those can decay into protons. And what do we call an element, which is made out of 4 nucleons in total, 2 being protons? Right, that's called indeed helium. So if one of those tripods snaps off, you get an helium emission. And that's not all of it. Now, the thing is, if you snap all 8 of them off, you will lose 16, a total of 16 protons, yes? You got 8 of those things, everyone has 2 protons, you lose 16 protons. Curium has number 96. Now, 96 minus 16 makes 80. And what do we find at 80? We find at 80, we find mercury. And since that means this object without those spikes, without those 8 spikes, you get this almost perfect globe. So that's interesting, I guess. I mean, gosh, you got an atom which is almost a perfect sphere, and it's with atom number 80. Mercury is liquid. We know why. It's like sticking your hand in a box of ping pong balls. You can move your hand around freely, but if those ping pong balls have spikes on them, they won't budge. You can move them. You can't even move them. It's solid. So this is why Mercury is liquid. Well, that's what alpha radiation is. Simple knockoff of a few, knocking off of those little tripods, those, what if you call it, those helium atoms. Small difference though with the helium we see in the sun. Helium in the sun, this is a chunk of the sun. This is how the neutrons, for the nucleons, are organized in the sun. This is helium when it comes out of the sun. You'll find it has only a core spin. It has, it's totally gridlocked. It has those two neutrons, the white and the blue are the neutrons, and the protons are those yellow, and the red one where there's one of those electrons sticking out. So both these are helium, but just a different form. Doesn't change anything for the radiation. Again, it's just a chunk of helium snapping off. So that's it. That's radiation, alpha radiation in detail. Have a nice day. Bye now.